Afternoon, everyone. Thanks for coming along to our March webinar for the Roads Transport Directorate. A few people still coming online, so we'll get started now, and others can just sort of catch up as they come into the session. So the focus for today's webinar is on two of our recently released publications, the Bridge Guide and the Bridge Design Guide. And our presenter today is Peter Mahar, who's the author or the lead author on both of those publications. Peter's also the CEO of Bridge Knowledge and a member of our Bridge Working Group. And I'll just flag the Bridge Working Group and acknowledge the other members of that group, who I think some will be on the session today. That group's been in operation since about 2004, 2005, so for quite a number of years, and has been quite instrumental in some of the Directorate's activities, particularly around the asset benchmarking project and securing the data that reinforces the need for programs like the Fixing Country Bridges. So I just wanted to acknowledge that group, and in particular Dave Andrews, who's the chair of that group, at the start of this session, because they've had quite an impact on the Directorate over 20 or so years. Look, I'll pass over to Pete now to take us through the presentation and details on the guides. And look, there are the chat and Q&A functions in this session. So if you have any comments or questions as we go through, please do pop them in there. And I believe Pete's happy to sort of answer questions as he runs through as well. So I'll try and keep an eye on that and just raise any questions from the audience as we get through the session. But Pete, I'll pass over to you now.
Thank you, Josh. Appreciate it. I'll just share my screen and we'll get into the presentation. All right, I assume everyone can see that.
Yeah, it's just on the presenter view, Pete.
Oh, okay. We'll just stop sharing and swap things around a bit. Apologies for that. Three. What about now?
Yeah, all good.
Yeah. All right. Apologies for that. Welcome, everyone. Thanks for the introduction, Josh. We'll get into the presentations on both the guides. So there's a fair bit to get through today. So if I'm moving pretty quickly, that'll be the reason why. So we'll give you an overview of both the guides. There is some time at the end for some questions and answers, and I'll stick around for those. Any burning questions you have during the presentation, by all means, ask. I've got no dramas. If it's relevant to the slide or relevant to the point we are in the presentation, we can have a quick discussion. Otherwise, there'll be ample time at the end, and I'm always available outside of this to answer questions as well on these two guides. So that's the way I'd like to run it. So feel free to stick questions in the chat bar, and we'll monitor them as we go through, like Josh said. So in terms of the guides, firstly, I'll look at the Bridge Design Guide. It's the second edition, so thank you for those that have been involved in the first edition. What's it look like? For those that haven't seen it, this is the front cover. I think Josh will talk about it towards the end, but it's available free for those members of the RTD. So just to give you an idea for those that haven't seen it, that's what it looks like. The purpose of it, Bridge Design Guide, was to look at investigation, design, construction and maintenance, primarily to assist local government team members involved in the management of bridge renewal projects in New South Wales. So it's really a heavy focus to assist local government, and particularly looks at guidance around what we call smaller bridge projects rather than the big Transport for New South Wales projects. It's important to note that the guide is not intended to replace the wealth of existing information and publications available in this day and age. There's a lot of Roads publications and other publications that are available, and it doesn't aim to comprehensively cover all the information necessary for bridge management. It's really a guide to point you in the right direction. So also, there's some really good Roads presentations and documents, publications around. They're free. This guide aligns with Transport for New South Wales. So the Bridge Working Party took the point of view for this guide that we are in New South Wales, and even though there may be better documents around in TMR or Vic Roads, we are in New South Wales. So we followed the transport, aligned with Transport for New South Wales. And just I'll bring this up a few times during the course of the presentation, but for bridge design, the Australian standard AS 5100 for bridge design, it's the standard that applies to all Australian bridges, and anyone who wants to use something different, you should be very, very wary. It is the standard, full stop. We will talk a bit later on about how you may vary vary that items in the standard, but it should be the go-to doc. And it's written in quite an easy to read manner, most of it, except when you get into the really theoretical part. So it's not that hard to read, and it's something you should have available. I understand it costs a bit of money, but it's well worth having as an available resource. So in terms of the guide, it's broken down into, I'll just get it up, for myself so I can read it as we go through. So it's broken down primarily into these key areas, and that's when you're managing a bridge, in terms of investigation phase, what you would do in terms of investigations, what you do during design, when you're replacing a bridge, the procurement phase, the construction phase, and the maintenance phase. We don't cover extensively in the guide. We point you in the right direction, because there's lots of good information out there around, and particularly around procurement. Councils are probably got their own preferred procurement models. So in terms of investigating a bridge for working out, you're going to replace it, we've divided it into the guide into three critical areas. Prelim investigations, these are things you can usually do yourself, and are well worth doing before you get into detailed design required investigations. And so the detailed design required investigations are investigations you really should do prior to the bridge design. You can package them up to a consultant to do both, but generally a hydrology and hydraulics investigation and a geotechnical investigation should be done before a design commences, or the formal part of the design commences. In terms of initial prelim investigations, have a look at council's records, get out and talk to, if you're lucky enough to have a bridge supervisor or a bridge team, what they know about the bridge. Even locals may know a little bit about, flood levels, those sort of things. Do a site visit. We encourage everyone to get out and have a site visit, view the bridge, do your dial before you dig. I think it's called BYDA now. I don't know what that stands for, but it's the old dial before you dig. For utilities, just have a check on state registers and your own council LEPs to see if there's any heritage listing. That can have a huge impact on a bridge design. So, you know, just get as much information. You might have work execs drawings on file if you're lucky enough to have those. Whatever you've got on file is very handy as you move through these phases. Moving into the detailed design required investigations, hydrology and hydraulics investigation, and geotechnical investigation. There's quite a bit of I guess, misunderstanding, confusion around hydraulic studies for bridges. So a lot of people just think, oh, well, if the bridge has currently got a 1 in 5 coverage, it floods once every 5 years. Statistically, we'll just build a new bridge at the same level and it'll have a 1 in 5 immunity, and we don't need any more information. In fact, you do need a hydraulic study for a bridge design. It's a key part of the design component. It looks at a couple of key areas. One of them is that a bridge under AS 5100 should withstand the ultimate limit state load, which means structurally it should still be standing. Doesn't mean there won't be any damage, but structurally the bridge should be still available for use for a 1 in 2,000 year flood. So that includes the effects of debris and scour. And so debris loads can be quite large in a flood, particularly as the debris builds up against the bridge just before it overtops. And then the other issue, so that 1 in 2,000 year is usually extrapolated from the 1 in 100 year information, and that's allowable under the code. And that looks at velocity and height. So velocity of the water and height that is going to be overtopped. And then scour protection is also looked at to be 1 in 20 in AS 5100. So it survives a 1 in 20 year flood, and you don't have, you know, in this case, although it's an older bridge, so probably designed quite a while ago, but you know, it hasn't had the capacity to take the volume of the water during a flood event, and that would either be scour protection or the actual size of the bridge and its capacity to take a flow. So quite important. I just wanted to make that point around hydrology studies. A simple 1D HEC-RAS study to get velocities and heights shouldn't cost you a lot of money. Really should only cost $2,000 or $3,000. So people think flood studies cost hundreds of thousands of dollars. A simple catchment study for a bridge or a culvert shouldn't cost you a lot of money. And then, yeah, I just wanted to labour on the hydrology and hydraulics. A lot of people get a little bit confused around that. Geotechnical investigation, at the end of the guide, we've actually got a sample document that you can use to go out and get your geotechnical investigations for bridge design. Key point there is you need to drill down to good strata. So you need at least 3 meters into a founding material, and that's usually intermediate to high strength rock. So no point going out and dropping a drill rig down to 10 meters, not finding any rock, pulling up stumps and then giving that to a designer. The designer is going to tell you, I can't design the bridge foundation based on that information. So at the end of the document, we have got a standard brief there that you can use with some ideas around how you handle additional drilling depths and varying those in a brief that doesn't cost you a fortune when the driller's out there. And then in terms of during the bridge design, you know, you'll have a road design component and you'll have environmental assessment. Some environmental assessment consultings or internal, you might be able to do that back in the phase before the design. Some require, you know, some prelim design information to go back into the environmental assessment. So just be aware of that all those things can relate to each other. The road design and bridge design, you know, can impact on each other. So you need to be aware of all those things during a bridge design and manage them accordingly. Again, just reiterating that the Australian Standard for Bridge Design, AS 5100 from 2017 is the required document. And then you've got the design phases. So typically, you can vary these. You do a 20% concept, which would only be a couple of pages, a plan view and a side view, but it just locks in the position of your bridge and gets everyone on the same page. You can jump straight to 50% design, just to, again, there wouldn't be a lot of detail, but it allows you to lock down the key details before you move too far ahead. You don't want to be moving the location of the bridge at 80 or 100% design. 80% design is typical. We generally recommend 50, 80, 100 IFC. 80s typically you've got quite a bit of detail, but there might be a few sections and some minor detail missing. Gives everyone an opportunity to review, things like bearings and traffic barriers and those sort of things. The design alignment for the road in a bit more detail. Then you'd move to 100%, which would be providing more detail and taking action on the 80% comments, and then really 100% to IFC should be just picking up any minor errors before you issue out the IFC issued for construction documents. I'll talk a bit about departures from AS 5100. So there's two areas that we see as common departures, and that can be easily documented. So traffic barrier assessment, whether you have no barrier, low, medium type traffic barriers. It is part of the design process, and you are allowed under the code to do a risk assessment, particularly for no barrier. So you can go through the AS 5100 appendice. I think it's Appendix A, has a flow chart for working out your type of traffic barrier, and you might come up with low performance. You can adjust that back to no barrier with a risk assessment, with things like debris build-up, traffic, and you can document that. The only thing I would say is run through that risk assessment and document the reasons why you've changed the barrier, and make sure that's kept on file, so that if there is an accident later on down the track, someone runs off the bridge, it's completely defendable because you've followed the code and completely protected. The other area is in terms of bridge loading. So SM 1600 is the current design loading in AS 5100. Now that's a 160-ton vehicle, stationary and moving. That's the SM. You might say, well, a 160-ton vehicle, we're never going to see that in our lifetime. Well, a bridge is designed to last 100 years. So the people who have written this code have looked forward and are thinking, well, we may have 160-ton vehicles running around in 100 years' time, and who knows. So that's what the code says. Now there is an option at the front of the code. It does say that the local authority can vary, and if you've got a bridge in the back of nowhere, it only services local traffic, and even the milk truck and a school bus and those sort of things, low traffic, you can go back to the old T44 loading out of the previous code, and that allows you to put a lower loading, which will be a saving. Generally on a smaller bridge you won't get a saving in the superstructure, but you will get a saving in the foundation, because your loading on your foundation, particularly braking loads, will be less. So there is a saving there, and there is in the guide, we reference a Transport for New South Wales document, which runs through, and you don't have to follow it line for line, but it's a bridge technical direction from 2014, which explains a bit of a process to run through a flow chart to determine whether you can allow T44 traffic loading. Now, I would say you don't have to follow that Transport One line for line. You could document something similar. But the important part in there that you need to recognise is that it is only the T44 loading and the loadings around that that change. And you need to be clear about that. Nothing else in the code should change. You're not going back to the old code when you go to T44. You're just using the T44, which is a 44-ton semi-trailer for your design vehicle rather than the SM1600. And that can cause a little bit of confusion. So hopefully that's clarified that a bit. If you still don't understand, happy to take a phone call or discuss at the end around the different bridge loadings. Other things you should consider when you're doing a bridge design, safety in design. It is a legal requirement under the WHS Act in New South Wales to do a safety in design report. Now, again, it doesn't have to be a Bible. It's typically 1 or 2 pages, but your designer should provide it, and that's documented. And we go through that in the guide where it comes from and where you can find more information around safety and design. Road safety audits. Many of you would know what a road safety audit is. Just something that we've noticed with Transport for New South Wales more recent funding is they are calling for road safety audits to be tied to the funding so that you have to do it. So just be aware what your council policy is and what the funding requirements are around road safety audits and whether you have to do one or not. The other area I wanted to talk about was just proof checking and verification. So often people think that proof checking and verification needs to be by an independent consultant. It doesn't necessarily have to be. I know some councils that we deal with just ask for a separate person within the organisation who's been not involved in the design. That's the only thing. They shouldn't be involved in the design process. Proof checking and verifying that it is per the code. Again, that shouldn't cost a lot. It's probably a day for a good bridge designer to independently check. If you go to proof checking and verification by an independent consultant, then that could cost you 7 or 10 grand, which you probably haven't got. So just letting people know that there are other ways that you can do proof checking and verification of designs, and it's always a good idea. Quality requirements in the design company probably should be doing it anyway, but it's not always the case, and it's something that you can ask for. The other areas covered by the guide are procurement, construction and maintenance. So just around procurement, we provide a bit of information around the 2 typical procurement models that we see in councils, and that's usually construct only. So the design and all the design documentation and the specifications and are done independent to the construction, and then the contract's let for the construction only, or design and construct. I know a lot of councils also these days are going to design and construct, where you let the design and the construction as one contract, and the contractor manages the designer. When you do construct only, you're managing the designer. Now, there's advantages and disadvantages of both, and I won't go into a lot of detail about those, but you should be thinking through that. And if you're new to a council, maybe asking what council typically does and why, to understand that process before you get too deep into it. It does take a little bit more work from yourself if you're managing the designer separately from the construction, but you're more likely to get what you want when you hand it over to the construction to do the design. You need to be very careful around any shortcuts around the design in terms of AS 5100, and you are getting what you want. So, if you want a 20 metre span bridge or a 12 metre span bridge in a location, you're not getting a 10 or an 8 or some other cheaper solution that doesn't actually match the environment. You can, just tie that down tightly in your procurement documents, and you're fine. But just be aware of the different risks around the different procurement models. The other area is construction, and it's more around construction documentation, and just making sure that you have your construction specifications, documented if you're using Transport for New South Wales. Bridge specifications, for example, that you understand the requirements of those specifications. Two of those that create quite a bit, or one in particular that can create quite a bit of angst among, during construction, is what's called B80, which is the concrete work for bridges transport specification, QA specification B80. And it is quite onerous as a specification, and you should be reading through that and being aware of it. It has got requirements around mixed design, reinforcement, the use of vibrating screeds on deck pours. So your local supplier of concrete needs to have a B80 mix, which may not be the case, which you can vary. If you're confident with your local supplier and they haven't got a Transport B80 approved mix, which is listed on their website, every plant that has got a B80 approved mix is listed on the Transport website. You don't have to use that if you've got confidence in your local supplier, but you just need to be aware of alkali aggregate reaction in aggregates up around Tenterfield and certain locations around the state do react, and you get block cracking later on in your concrete because the aggregate slowly expands because of the reaction with the cement in the concrete mix. So B80 is quite onerous, but it's written over decades of experience and mistakes that Transport have made. So just be aware of those. Maintenance, you should always be considering maintenance in your bridge design as well. And then there's quite a good in terms of maintenance of bridges outside of the design. We've only got a short section in the guide on that, but we strongly reference the Guide to Bridge Technology, Part 7, Maintenance and Management of Existing Bridges. It's an Roads publication from 2020, updated in 2024. Very good publication, free to download, should be in your library. And then at the back, we have a heap of references. As you'll see, a lot of Roads documents. As I just stated, they're all free. Why do fish need to cross the road? That document, which is also freely available, is the one that fisheries go to for your DPI permits. When you build a bridge, you need a permit to enter the waterway, and they will always, particularly with box culverts, they love going to this document. So it's a free document, easy to have on hand. The Bridge IPWIA guides, the Safe Work Guide of Code of Practice in terms of safe design of structures. That's your safety and design. The standards, unfortunately, yes, you do have to pay for, but you should be asking your council to provide you with AS 5100. It's not that hard to read. And then, sorry, I've jumped ahead. And then some transport guides around bridge inspections, and B80 is also, the transport guide we've referenced there, the Bridge Technical Direction for Traffic Loading for Bridges. So that's for using T44. Great information. You don't have to follow it word for word, as I've said before. It's good information. And then the B80 spec, bit harder reading, but well worth knowing if you're in the bridge game and want to stay in the bridge game for a while. So that's the finish of the bridge design guide. I don't know if there's anything, I can't see the chat bar, Josh, but if there's anything urgent or people want to bring up on this one before we get to the Q&A at the end?
Yeah, there's no comments just yet, Pete. But,
All right.
I'll keep an eye on that, and if any pop up, I'll let you know.
All right, thank you. All right, so over to the bridge guide, which is called the Bridge Inspection and Maintenance Manual. It's the third edition of this document. It looks like this. And again, RTD members, it's free for you to download. Similar purpose behind this document. It's specific to local government. It's not meant for use by others. It really looks into the inspection, condition assessment, prioritisation and programming of tasks associated with the management of bridges in local government in New South Wales. So really around the whole bridge asset management process. It does have a focus on timber. However, there is some guidance in the guide around where to find information on steel and concrete bridges as well. So the Bridge Working Party really wanted to hone in on timber because we felt that there's not a lot of information out there for local government engineers to specifically look at timber bridges, particularly in New South Wales. So asset management of bridges, why do we do it? It's really about risk management. I found this was after a bridge collapse in Italy, a large bridge collapse. The media got onto it, but there was a professor in one of the unis called Dr. Caprani, and he estimated that 70% of Australia's bridges are more than 50 years old and are beyond their design life, and warning of the risk of a bridge failure in Australia, whether it be a total collapse or something minor, with worsening traffic and the push to introduce what he calls automated truck platoons, but be larger legal loads. And I think there's talk about B triples running on part of the network, not that far west. So it's really about managing the risk. And I guess anyone from council with a reasonable number of bridges in their inventory would understand that a lot of them would be more than 50 years old. And certainly in our experience, it's generally, we find that the average age of bridges is increasing each year. We're not replacing them as quickly as we built them many years ago. And then just the different risks between road and bridge. I'm a bridge engineer at heart, got bridges running through my blood. So I'll always say that bridges are more risky than roads. Clearly you could hit a pothole and have a nasty accident, but I think the picture on the right, which is in Australia, from 3 or 4 years ago, overloaded truck, or I presume he's overloaded, or the timber bridge was in poor condition, and that's where he ended up, very lucky. So managing the risk of your bridge inventory from an asset management viewpoint is very important, and that's the reason for this document is to assist with that. So, excuse me while I just bring up that guide.
There's a comment from Tony Likas, Pete, that the bridge, I'm presuming the one in the photo, had a level 2 done about 3 months before that incident, and the truck was legal. So
okay, yeah, well, I was speaking, I guess, out of turn there. I didn't know the circumstances. I was just lucky enough to get the photo. Tony's bridge, obviously, bridge Tony was aware of. So
Kyogle Bridge.
Kyogle Bridge. Yep.
Yeah.
Thanks, Tony. Yeah. So this guide heavily follows the guideline, the Roads guideline, engineering guideline to bridge asset management from Roads in 2021. So that's a key document that should be read hand in hand. Like, it's quite an extensive document. It's potentially more aligned to larger bridges, but it's still got some really good information for those managing, a local government inventory and we just tried in the guide to provide a bit more context around for local government. One of the key things when we look at bridges is what is a road bridge. So we've used the transport guide there, and that says that any whether it's a box culvert or a bridge, any structure that goes for more than 6 meters along the road is a bridge. So transport actually define your larger box culverts as a bridge. They exclude pipes and anything that's a fauna or cattle underpass, or generally they're an underpass. I have seen some overpasses. They also classify as a road bridge, even though it's only for stock or fauna. Now, you generally see those on the Pacific Highway. I'm not aware of many council ones. There used to be one up the Tweed that carried a dairy herd, an old timber one. I don't know if it's still there or not. And then, yeah, we then run through what we believe are the essential parts of getting a bridge management philosophy, or building towards asset management through the guide. So the critical areas in that. We'll just jump back. Sorry, we'll get into bridge inspections in a minute. Is in terms of assuring that council's got resources allocated to bridges. That doesn't mean they're dedicated. You might have someone that's looking after bridges and something else, but at least someone is, responsible for the bridge inventory. Develop and maintain a library of materials, so a lot of references, and I've talked about a number of things that are freely available. Create something on your D drive or on the council drive with these documents. They're all, some of them take a bit of reading, but there's a lot of information in there that you can easily use. And if you've got them all download them all and have them in one place. When you have an urgent issue, it's easy to jump into the relevant document. Establish an inventory. Most people these days, most councils have got their inventory. And then, as Tony was talking about, you need to be inspecting your bridges on a regular basis. So, we'll get into a bit more detail later on for timber bridges, what the transport recommendations are. You don't have to exactly follow transport, but I'd say you definitely should have something documented. If you're going outside of what transport is saying, well, that's fine, but just have it documented. And then, yeah, just developing some costings around, how you're going to improve and your inventory, and we'll get into that in a bit more detail. So I just wanted to talk about bridge inspections in terms of the Transport for New South Wales documents. And there are 2 Transport for New South Wales documents. So they're the only agency that uses 2 documents to explain their bridge inspections, which can be quite confusing. So if you download their manual, all you're getting is a manual that tells you how to do a bridge inspection. Now, it's quite a good manual. It's pretty old, so it's a little bit out of date compared to some of the other agencies around Australia, although it's got some great photos, for condition assessment in that document. But then they've also got a policy, and we reference that policy in this guide. That outlines what the different inspections are and how often you should do them. So, we often get phone calls from people saying, we've downloaded the transport manual, we can't see anywhere in it that it tells you when and how to do your inspections. So that's in a different policy document. You need to have both. So level 1 inspections are generally just a drive-by. Typically, you wouldn't be getting out of the vehicle. It could be done by your road inspector, just trying to pick up any obvious safety issues on a bridge. They could be just that someone's hit the guardrail, there's a bridge joint loose, or in a timber bridge, it's rattling like hell. Just picking up those sort of things. The level 2 is the condition rating, where it should be conducted in accordance with the bridge inspection procedure. and by certified bridge inspectors. Now, I'll talk a bit about that a bit later on in the presentation about certified bridge inspections, or on this particular slide. But you condition rate every element in the bridge in a level 2 and document it. And usually, the required maintenance actions will come out of that level 2. In New South Wales, a level 3 inspection is combined usually after a level 2, or could actually be combined with a level 2, but it involves a bridge inspector and an experienced structural engineer, and you're actually doing an inspection of the bridge with those 2 people picking up more critical items. And you would use something like an under-bridge inspection unit. The general rule of thumb is there you should be able to touch the element that you're looking at, whereas a level 2 you can do with binoculars. You can do in different manners. You don't have to get up close and personal to things like bearings. And then a level 4 is a load assessment. Now, that can come out of a level 3, or any changes, particularly in transport. They might have changes in legal loadings across their network. I guess councils have the same thing. Or there might be a new vehicle type, and you need to confirm the structural capacity of the bridge. Now, in the transport document talks about RMS certified. So it's an old document when transport was Roads and Maritime Services, an RMS certified bridge inspector. There's not many of them around, and it's almost impossible to get into the RMS course unless you're in RMS. So, in our opinion, and councils, you should be just documenting. It's replaced by an appropriately trained and experienced bridge inspector. And, it's as easy as that. They don't, in our mind, there are IPWIA, there's an IPWIA level 2 course. I think there's an Roads course. There's other courses around, or there may be just a supervisor who's been around for a long time and knows a lot. So, appropriately trained and experienced. I wouldn't get into too much unless they're young and green around the ears around certification. There is an IPWIA, a document called the Bridge Inspection and Load Assessment. And in the appendix, I've just shown you here, there's a bridge inspection type comparison table. I've just shown you Queensland. There's one for nearly every state in Australia, and the AS 5100. So it defines, so it's a great comparison table between the different states and how they do inspections. So you'll notice in Queensland, they don't do a level 4. They only do a level 3, whereas New South Wales, they do they separate level 3s and 4s. AS 5100, for example, only has 3 levels. But this document, again, is available on the RTD website for members. Great appendice in it, Appendice A, which does a comparison across the key jurisdictions in Australia around bridge inspections. So when you've got someone telling you about a Queensland inspection, you can very quickly, or a Vic Roads type inspection, you can very easily go and have a look at that table and look at what the transport one is. So just wanted to highlight that is available and a great document. Again, you should be, this is just a guide. It's a quick reference guide. You should be going to the actual procedures or manuals in the relevant jurisdictions if you want to really know the detail. In terms of bridge management, it's typically broken down into bridge maintenance, which is just your typical maintenance items, bridge rehabilitation or renewal, or bridge replacement. Now, in terms of when we talk about bridge rehabilitation or renewal, really looking at what we call a capital works task. So different councils might look at this differently, but generally will involve a relatively large expenditure, which enables benefits expected to last beyond a short time frame. So in a timber bridge, you might be, replacing a couple of girders and the whole deck or something like that. Or major works on a concrete or steel bridge. You might be painting a whole steel bridge, for example. We would put that under bridge rehabilitation and renewal in terms of a management philosophy and doing an asset management plan, because they're larger expenditure. Your bridge maintenance generally should be around the same sum of money every year, plus inflation, for your crews or contractors to go out and do your general bridge maintenance across your network. And then you get into bridge replacement. If you decided a bridge is beyond its design life, for whatever reason, then you can go back to the previous guide and look at, what you would do around planning that bridge replacement. Bridge inspection and financial management. So we're going to get into a bit more detail here around bridge information and data collection, your bridge inventory, and particular timber bridge inspections and testing methods. Sorry, I've just jumped ahead one there. So in the guide, we get into a fair bit of detail around timber bridge inspections. So why we've done that is timber bridges are vastly different from an inspection regime than a concrete or steel bridge. And typically, if you want to do a level 2, Transport for New South Wales recommend in their methodology a test bore every 4 years. And a test bore would allow you to check the actual internal rate of decay of timber. Timber often looks great on the outside, but may have significant deterioration internally. The guide leads you through quite a bit of detail in terms of a level 2 inspection, how to do it for a timber bridge, what it involves. In particular, in terms of a level 3 and a level 4 for timber bridges, we outline the details in AS 5100 of the different ways you can inspect and do a level 3, level 4 load assessment of a timber bridge. So there's various technologies that people are out there selling. AS 5100, which is the code and the one that that guides everything around bridges, only allows a couple of different methodologies, and they are visual inspection and a load test, so a test under load and measuring deflections, for example, an inspection with timber boring, and that's a traditional large diameter timber test bore that's been done for years and years, usually with hand resistance measured by the actual person doing it, so someone who's very experienced at doing timber test bores. Nuclear densometers, quite expensive, and I'm not aware of anyone who's used that. Drill resistance testing, which is basically modern test boring. You use a smaller bit, and the drill actually measures and can print out the resistance as you drill. And then assessing material and section properties. Anything else is not compliant with AS 5100. So I have some particularly strong points of view on this, so I won't get into those, but there are people are running around with all sorts of fancy tests, giving you a load assessment on a timber bridge. I would be asking them, do they comply with AS 5100? Because some of them clearly don't, and then you get a false result, and then you got to live with that. So the guide gets into a fair bit of detail around those issues, just to provide guidance on the Transport for New South Wales, and in terms of across the other jurisdictions around timber bridges. You'll find that Queensland and Victoria, the main other two, Western Australia's got quite a lot of good information as well. But Vic Roads in Queensland and Transport are all very similar in terms of their methodologies. It's just their naming conventions between level 3 and level 4 that differ in the timber. So quite a bit of information on the guide there, because we just felt there was a bit of confusion in industry around that. Putting together a 10-year bridge management plan. So you'll have a difference between OPEX and CAPEX budgets. So most councils are running a year-to-year operational budget for your maintenance, but they're CAPEX. So when you get into the major rehabs and the what we call renewal, and the reason we use renewal is that aligns with Roads documents, would be under CAPEX, and a replacement would be under a CAPEX. So you'd need a specific budget to do those works. So when you're planning out a 10-year plan, you need to be differentiating between your yearly maintenance cycles, where you've got a pretty consistent budget, hopefully, to do your bridge inspections and maintenance across any given year, and then what CAPEX you then require to do your renewals and your replacements. Estimating, you'll have to do some sort of estimate around your renewals and your replacements. I always say estimating is part art, part science. It's not all science. So in terms of art, ask those in your council, particularly those that have been around for a while, what are the typical square metre rates for a bridge replacement? What are the typical rates for replacing a girder on a timber bridge, redoing a deck? Your council should have a lot of that information. So what we would recommend in a 10-year bridge management program plan, that you're probably looking at year 1 and year 2 in quite a bit of detail. So you're probably applying more science there, where you're getting down into individual elements and trying to get reasonably accurate budgets. And then as you go out, it's probably more art, where you're having a bit of a guess based on experience and the experience of others of what a bridge is going to cost to replace in the future. So don't forget to apply some inflation, some average inflation around that. And rely, talk to your neighbouring councils if you haven't got any older, more experienced people around the bridges in your council, or give someone like ourselves a quick call, particularly around new bridges. We can give you what we believe is the current rate per square metre on a bridge in the industry. Then we provide a bit of guidance. Then you've got to work out, well, what am I going to do first? And there's lots of different decision methodologies around, whether I'm going to replace bridge A, B, or C, and which one I'm going to do first, and things like school bus routes and AADT, and whether the mayor lives down that road, will all come into it. So we've outlined, the last one was jest, for those of you who don't take it seriously. But yeah, there's lots of different, decision points that will go into where you might start first. And we've outlined in the guide some different methodologies around how you might go around doing that. I'm just bringing up the right page so I can reference them. But there's decision methods like whole of life costing, net present value. There's just risk-based decisions, multi-criteria analysis, where you have various analysis like the school bus, like traffic, like whether what rate, what type of road it is. So your council might have regional roads and local roads, so you might do more on regional, local, or your local roads might be ranked at different levels, and then you can apply different models. And your council might already like one of those models, but we've provided a little bit of detail, and there's quite a bit of detail in the Roads reference document around these different decision matrices and what you can use to make these decision methodology for putting together a 10-year plan. And again, it's a bit of art and a bit of science. Your bridge asset management plan, where does it fit? Our understanding is that under the new government requirements, a bridge asset management plan would sit within council's transport asset management plan. Generally, from our understanding, the road plan will include a bridge component. So that's where it sort of fits in the overall framework. You know, what are the key components? We've just gone through how to get there, and then you'll have a 10-year plan that would outline, you know, what dollars you need at what stage. Generally, you'd have all the bridges listed on the left-hand side, and then on the right-hand columns, you'd have, you know, what year 1 to 10 across the top, and then whether they're renewal, rehab, and what dollars you need, and then your bridge inspections and bridge maintenance, typical maintenance would run across the top. But we don't go into much detail in the guide around that, because the Ausroad guide actually goes into quite a bit of detail and has got an example. So they're good places to go. What else should you be looking at? Definitely a bit of risk management that may be in your decision procedure, may not be. So, you know, where are your riskier locations? That might be, you might have a very poor bridge that you know of, and it's, you know, it's in a highly trafficked location. Heritage can be a consideration. So again, whether it's on the unusual, if it's on the State Heritage Register and a council, but it does happen. You can go onto their website, see what, if you have a bridge there, and then you might have bridges that are listed in your local LEP. That, you know, is a whole different ball game when you get into heritage, but it's well worth checking on early on before you go too far down the track, because it can have a large impact on the outcomes if it's heritage listed. And then any environmental considerations you should be looking at just generally as you work through it, in terms of protection of the environment. So, you know, is it in a known area of high environmental impact? You know, as a council, you've probably got a general idea of locations within your council area where that may be the case and where it's not so much of the case. You may also be looking at bushfire considerations in this day and age as well. So whatever that, you know, that might come back into more in risk, but, depending on the location. And then reference documents. We've got 2 pages of reference documents in this guide. The first page is best practice bridge management guidelines. You know, a lot of Ausroads guides there. All of those things. There's the 2. I don't know if you can see my mouse, but the 2 transport documents there in terms of their policy, which tells you about when and where, whereas their manual talks more about how. Guide around maintenance and management of existing bridges. The engineering guide to bridge asset management, number 2, is quite good. The ISO 55000 suite, depending on if your council is certified or not, is very high level. And I would only reference it if your council's certified to that, and you need to be aligned with it. And then Ausroads documents, and then the Roads and Transport RTD Directorate publication from July, where I showed you the appendice, but that's also a good little guideline around bridge inspection and load assessment. And then the New South Wales Roads and Traffic Authority Timber Bridge Manual. I believe it's still online. It was never actually officially published, but it can be found online. Is a good guide around timber bridges. And then just the reference documents that we've used to bring the guide together. So that's on page 26 and page 28 of the guide. So that's a very quick run through, a lot to chew through in an hour. So apologies if I've run through that very quickly, and happy to take any questions.
Thanks, Pete. Appreciate your time and certainly your work on putting these 2 guides together. I think we're pretty much out of time. I think we've got about 1 minute left. So if there are any questions or comments for Pete, please do pop them in the chat now. Conscious that some of you may need to drop off for other commitments, but Pete and I are happy to hang on the line for another few minutes if there's any particular questions. As has been mentioned a few times, you can access, well, all 3 of these guides, the 2 that Peter just covered and the quick reference guide through the RTD website. We have actually just relaunched the website but the resources page, is slightly changed, but you should still be able to access the guides through there. If you have any issues, please do come to me or the team, and we're happy to chat about it. So yes, if you do have any questions, I'm not seeing any at the moment. We'll wait for another minute or so. I'd also flag our next webinar will be on the 30th of April, and that's an update from Transport for New South Wales in regards to their latest road design updates. So that'll be a good one if you're involved in that space. Look, oh, here comes a question. Oh, thanks, Will. Yep. Yep, absolutely. As Will's just said in the chat, there's our email address if you need to get in touch with us. Look, I'm not seeing any questions, so we might wrap it up there. Thank you, everyone, for your attendance. And Pete, thank you very much for presenting today. And yeah, hopefully we'll see everyone at the next webinar.
Thank you.
Enjoy your afternoon. Thanks, everyone.
Bye.